Welcome back for another VMK in the C++ series. In this VMK, I'll be discussing how to generate random numbers in C++. I'm going to jump right into Visual Studio. I'm using Visual Studio 2008, but this applies to 2005 and earlier versions as well. I've written a very simple console application program where you can see I create a file called numbers.txt. I'm going to be writing text into this file. What I'm going to do is I'm going to go inside of this for loop for the total number of times that I've specified here inside of this variable. So right now it's set to 10. I'm going to go through here 10 times, and each time I'm going to be calling this create number function where I pass in two parameters, the minimum value and the maximum value. And the minimum and maximum value are used to generate a random number based on this range that I specify here, and the random number that's generating is based on this rand function that's part of C++. So this is going to generate a random number. We use the modulo operator, adjust the min-max value here with an additional minimum offset here, and the resultant value should be some random number generated between the minimum and the maximum. The number that gets returned here, we're just going to fprintf into our file, and then once we're done for the number of iterations, then we're just going to close our files so that we have all of the random numbers that are generated saved inside of this numbers.txt file. Let's give this a run. I'm going to press Ctrl F5, and you can see that it quickly finishes because I'm only asking it to generate 10 numbers. Now if I go into the folder here where my project resides, you'll see there's a number.txt. If I open it up, you can see I generated these 10 numbers, 55, 44, 54, 00, and 42. Let's close this off. And you would imagine that if I were to run this program again, it would generate 10 new random numbers, and those numbers would be different. However, that's not the case. Notice that if I run the program again, and I once again go back into my folder here and open up the numbers it generated, you see we have 5544, 54, 00, 42. The exact same random numbers are generated again. And no matter how many times you run this program, it'll always be generating the same random numbers. I can change the numbers if I change the range. For instance, if I say please generate 11 numbers rather than 10 numbers, now if I save this program, rerun it, and take a look at the output, you'll see now that we have 5544, 5400, 425. So the last number is obviously different because we've specified we want 11 numbers. Or if we want a different arrangement of numbers here, we can also change the range that we're going here. Instead of 0 to 5, let's say I want numbers from 1 to 5. In that case, when I rerun the program and now take a look at the output, we see now we have 2351, 5544, 351. And again, if I were just to rerun this again, now the random numbers that it's always generating are this set here. So what's up? Well, this random number generator that we're using here generates a number between 0 and a specific maximum number value. If I go into MSDN, we can see precisely what is the range that it's generating around. Here in the remarks section, we see that this is a pseudo-random integer that ranges from 0 to random max, which is a value of 32,767. This random number generator seeds all of its random numbers using this function here called srand. So if we want to randomly generate random numbers every time, then we want to seed our random number generator to a different value every time we run our program so that our random numbers that we're generating are different. So here's how we would do that. Right before we call our create number, which generates a random number, we want to call srand, and the parameter that we pass in here is very important because we want to have a different value in here every time we run our program. And the way we can get a different number is by using the time function call, because then it'll return the time in seconds, which we can convert to an unsigned integer, which we pass into this srand function. So every time we run our program, time is obviously going to increment. Therefore, srand is going to have a different seed value. Thereby, our random numbers that is generating are going to be different every time. So let's give this a try. If I run this through this time, we have the following numbers: 5211, 53, 53, 512. If I run it again, and now take a look at the numbers, we see we have a different set of numbers. We have 5233 to 545451. So now we're generating different numbers every time. If we want to have a predictable random set of numbers, we can just change our seed to some number, let's say seed of 1. If we do that and we run our random number generator, then for a seed value of 1, these are the random numbers we're always going to be generating. For a seed value of 2, then we're going to be generating a different set of random numbers, but these random numbers are always going to be in this order. So that's the way that the seed function works. Alright, so I'm going to return this back down to what it was here with the time, so that every time we run through, we're going to have a different set of random numbers. Now, one thing I wanted to describe here is how to generate random numbers. Now, I'm only talking about integers in this VMK. If you want to see how this is done for floating point numbers, I recommend you take a look inside of the Ghost Host VMK series. I just finished uploading a General Math Update VMK number 22, which discusses how to randomly generate not only integers but also floating point numbers. The formula is a little bit different. I've showed you here how we can generate random numbers for integers using the modulo operator. Problem is, you don't want to use the modulo operator if you want to rely on a nice even distribution of your random numbers. Here's what I mean. What I'm going to do is I'm going to crank up our total number of numbers that we want to generate to, let's say, 100,000. So we're going to be generating 100,000 different random numbers, and all the random numbers I'm going to be generating are going to be ranging between, let's say, 0 and 30,000. Okay, let's run this through, and it's going to create a text file for me. So here's all the numbers, and if we scroll down to the very bottom, we see we have 100,000 numbers, and each of these numbers are some number between 0 and 30,000. Let's go analyze these numbers to see what is the distribution or what is the histogram of these numbers. I can do that quite easily using Excel. I'm going to open up Excel here, just drag and drop my numbers.txt file into here, and it'll automatically populate a spreadsheet for me for all the numbers that were in that file into cell A. There's an automatic histogram function inside of Excel in one of the add-ons. If you take a look inside of the tab called Data, at the very end here, you'll have an analysis where you can click on to do a data analysis on some numbers. If you don't have this tab showing up here, you just need to go under Excel Options, under Add-ins, and you want to go ahead and select Excel Add-ins, click Go, and you want to click on Analysis Tool Pack, and you can also click on Solver Add-in. That'll allow you to have these two guys here to be able to quickly generate histograms. Alright, so the way that we generate histograms in Excel is we need a column of data. Those are our numbers, our random numbers, and we also need a second column which will represent our bins. And for a histogram, you know that on the x-axis we have our individual numbers that we're looking at. On the y-axis we have how often each of those numbers showed up. So we need to specify what is our x-axis range. Well, we know that we're going to have numbers ranging from 0 all the way to 30,000. So what I'm going to do here is just quickly create a column of data from 0 to 30,000. Scroll down here to 30,000 and copy that formula down. So now we have two columns. We can hit the data analysis, select histogram from the tools, from the analysis tools, and in the first input range here we want to select all 100,000 numbers that we generated. So we're going to go from A1 to A100,000, like so. And in the second column we want to choose all of our ranges, so we're going to go from B1 all the way up to 32,001. Then we hit OK and we just wait. Oh, I forgot to mention there was one of the checkboxes at the very bottom that was checked to create a chart, and that's going to give us this plot here for us to look at. Now if we take a close look at this plot, we can see how often each of our numbers were generated. You can see along the bottom are our bin values, so those are the numbers between 0 to 30,000. And on the y-axis here we have our frequency, how often each of these numbers showed up inside of a random number generator. Let's just delete this to expand our graph a little. And we can see that on average we're generating each of these numbers here about 7-8 times. However, these numbers in the lower end are generating more frequently. And this is a function of using that modulo operator. We see if we wanted to have a nice equal distribution of all the numbers, we should see the same sort of rough average line running straight through from 0 all the way up to the maximum bin. But when we use the modulo operator, there is a skew, and the skew is going to show up inside of the lower portion of our bins. So in other words, the numbers from 0 to, what is this here, 2,579, those numbers are showing up more frequently than all these other numbers are. So if you're doing some sort of simulation and you're relying on having a nice even distribution of numbers, you'll want to make sure you're not using your random number generator that is created using a modulo operator like shown here. To fix this, we just need to change our function that we use to calculate our random numbers. Instead of using this one here, which has the modulo operator, we can write this function here, where we're taking our minimum and maximum value, adding 1 to it, multiplying it by the random number, and all of that we're dividing by randomx plus 1. Finally, all of that is added to the minimum value. So this expression here is going to generate a number between the minimum and the maximum. However, this distribution is actually going to be a lot better looking than the previous equation we were using. So let's give this a try. We're going to run through, generate some numbers. Actually, let's go into here, close this off, make sure that we're not interfering with that file, numbers.txt. Run this again. Okay, we've generated some new random numbers. Now we're going to open up Excel, take those new numbers that we just generated, open them up in here, and again, we've generated numbers between 0 and 30,000. Then we're going to take that number, add 1 to it, drag this equation down to 30,001 to encapsulate all the different bins that we have, right down to here. Hit the data analysis, click on histogram, and in here you want to specify your input range, those are your random numbers, your bin range, those are the numbers from 0 to 32,000. Down here we want to have chart output checked so that we actually generate the chart. I forgot to mention that last time, and then hit OK. So now it's going to generate for us the new sheet with the results, and it's also going to create that histogram for us to see the results visually. And here they are here. Now notice that the histogram is a lot smoother. There is no skewing of the lower end numbers, meaning that the probability that each of these numbers are being randomly generated are about equal. You can see that they're ranging around 9 or so for each of the numbers. So to sum things up, when you're generating random numbers, integers for instance, as I'm showing here, you want to be using your sran function to randomly seed your random number generator, which is this guy here. This guy here is generating a number between 0 and rand max, and if you want to create a number between some minimum and some maximum value, here's the equation you can use to give you a nice even distribution of all those random numbers. If you have any questions about this VMK or any other general questions, feel free to go into the forums, and under the forums there will be a section here under the mathematics, under the C++ VMK series for this specific VMK, where you can post your questions on how to generate random numbers and things like that. Or if you have any other questions, feel free to post under any of the other forum sections.